Good afternoon, class. We are now going over lesson 2 of Unit 10, the guided practice portion, to help you um, expand your knowledge on yesterday's material about similar triangles. So today we're going to be looking at the properties of similar triangles and finding unknown side lengths using some new properties. Anyways, this is from page 878. We're going to do guided practice number 1, 3, 5, and 8. So the first problem says if triangle AB, the side AB is equal to 3, and AE equals 1, and ED is 12, it wants us to find AD. Well, what is side AD? Side AD is that big portion. So side AD is going to equal AE plus ED. And that's going to give us 1 plus 12, and that's going to give us 13. So AD is 1 plus 12. All right, so that is number 1. Number 3 says if we have this triangle over here that are two similar triangles, it says if XY is 76, so this whole entire thing right here is 76, and XW is 19, XV is 18, so 18 right here, and XZ is 72. It says determine if VW and ZY are parallel. Well, we know that they're parallel based on a property that was discussed in this section. Essentially, we have to do what we did yesterday and looking at proportions. So if they are parallel, that means that we can say that side XW over XY is equal to side XV over XZ. And if that's equal, then we know that it's parallel. So if this side of this smaller triangle, XW, over the other triangle side, XY, which is 76, is equal to XV over XZ, then we know that they're parallel because the ratios will be the same. So XW is 19, XY is 76. Does that equal XV, which is 18 over 72? So that is the question that we have to look at. So we are going to solve that right now. So again, it is XV, which is 18, over XZ, which is 72, and 19 over 76. So what I want to do is see if 19 goes into 76 evenly. And it does. So for this problem, we can divide the numerator and the denominator by 19, and we're going to get 1/4. So then let's look for 18 over 72 if we're going to get 1/4. So let's divide both sides by 18, and that's going to give us 1. 72 divided by 18 is 4. So these actually equal each other. So yes, we have proven because the proportions of the sides of the smaller triangle to the larger triangle are equal to each other. So yes, VW is parallel to XY. So that is number 3. And it's because 1/4 equals 1/4, and we proved it. So these two fractions or proportions equal each other. All right, so we are going to move on to problem 5 and 8 of the guided practice. I'll give you a second to write that down, and then we will move forward. So let's go on to problem 5. So problem 5 says RS is a mid-segment of triangle MPQ. Find the value of X. So I'm going to draw this triangle M, P, and Q, and it has RS and this little side that comes from R to the mid segment of triangle MPQ. So PQ's length is 38, and it says RS is the mid segment of triangle MPQ. Find the value of X. So essentially, this I drew a little bit inaccurate. It's supposed to be the mid segment, so I'm just going to try to draw it halfway through. So that means that 38 divided by 2, and that is 19. So that means that this little portion right here is 19, and this little portion right here is 19. So it says that we want to find the value of RS. So what we're going to do in this circumstance, this is an example from example 3 in the textbook. So that would be, if you want more clarification, that is going to be on page 875. And essentially, there is a formula that we use that says that if we're looking at mid segments of a triangle, it's actually 1/2 of the larger portion. So what that means is X is going to equal 1/2 of PQ. So what that means is if PQ is equal to 38, X is going to equal 19. So RS equals 19. All right. I know I cut it in half for these two down here and said it's equal to 19 because that's what a mid-segment does. It creates two equal portions, but that is pretty much how we solve that problem. If we have a mid-segment, there's like a theorem that says that this small base length of MRS, triangle MRS, is going to equal to 1/2 the base length of MPQ.